Hi, this is Team Regor with the Team Regor Smart System Case Study Project. The members of Team Regor include...
Hi, I'm Zachariah Buck. I'm a tooling and manufacturing engineer for Fronenberg NOK in Franklin, Indiana.
Hi guys, Warren Cuerpo out of Los Angeles, California. I work in a material process organization for an aerospace and defense contractor.
I'm Mark Galligot. I'm a biochemical engineer with a company called BioX in Windham, New Hampshire, focused in biotech and pharma solutions.
My name is Mohammed Siraj. I am a product manager at Continental Automotive Group in Allentown, Pennsylvania.
The Polywood manufacturing system utilizes intrinsic manufacturer monitoring and control sensors in each unit operation for their manufacturing process. From recycled plastic grinding to final product assembly, Polywood utilizes recycled plastics and an extrusion, milling, and assembly process to make lightweight, durable outdoor furniture. In this presentation, we will analyze the shortcomings of the Polywood process as well as recommend enhancements to decrease variability as well as improving product quality.
After a thorough analysis of the Polywood operation, our team found the system lacks optimal visibility of performance in the individual processes along the manufacturing effort. Polywood's processes are performed by manually operated machines or heavily dependent on human resources. The absence of detailed information of the system's performances raises questions about the quality of the production and the efficiency of the entire process. It's clear the system's absence of optimal data collection and analysis spawns a technology gap between current developments in smart manufacturing and the defined process. We assume Polywood's aim is to eliminate the potential for manufacturing defects, reduce the amount of rework, and decrease the percentage of scrapped goods. Throughout the different phases, we see missing points of control that can be mitigated with solid information. So, to summarize our problem, we recognize a need to expand the clarity of performance in the individual processes of Polywood's operation, and we must pose the question, imagine we understood the performance of all aspects of the Polywood operation and possess the ability to make real-time changes to optimize the process. What would that look like? Next slide, please.
As we said, Polywood's operation is split into three parts: recycling, extrusion, and assembly. Their operation seems to be just on the edge of using Industry 4.0 methodologies. To start, the recycling process is still very manual as machines transfer the process and materials to one another with minimal monitoring systems. Their extrusion process has a lot more when it comes to sensors. They monitor speed, feed, temperature, and weight, but all the variables are controlled by human operators. They eventually fixed this by implementing data collectors to newer machines, but the touchscreens they talked about don't necessarily mean that they're interconnected. Their assembly process is almost completely manual. Though the scheduling software does organize the process, everything is picked by humans, which can still incur error. Next slide, please.
The enhancement proposal Team Regor believes would provide the largest benefit for Polywood was the incorporation of the use of the cyber physical system for zero defect manufacturing. Since there's a heavy dependence on manual operations at Polywood, we developed an enhancement strategy utilizing existing and new sensors to reduce variability, decrease scrap, and reduce rework while improving quality would provide the biggest benefits to the manufacturing operations. Foundation of zero defect manufacturing, in essence, is a comprehensive data acquisition system able to collect and synchronize data gathered from different heterogeneous, multi-resolution, and multi-scale data sources distributed in the production line and outside. GDM is analogous to computer-aided quality, since the concept to reduce waste and reduce rework is aligned with maintaining a high level of quality assurance. The implementation strategy for the zero defect manufacturing is to first utilize the sensors already in use at Polywood per phase across each unit operation. These sensors have been previously outlined in the operation review section. The initial phase of this project would be to identify the existing sensors, what they're measuring, what they're controlling, and then there'd be a review of this of the relevant data being collected and how often it's being collected. The sensor monitoring and controlling data will be combined with requirements data-driven data analytics outputs. Then we would run some process simulation combined with those data analytic packages to inform which unit operations or phases can be mapped to the biggest benefit in achieving the manufacturing process that aligns with zero defect manufacturing. However, it doesn't stop there with just the sensors. It also incorporates outside of the sensor technology by pulling in information from ERP systems, manufacturing execution systems, as well as local controls, data logging, and other manual data capture within the manufacturing process. The new rollout to be vetted by an analytics software informing manufacturing operations on a critical data path collection will happen through a third-party integrator. We recommend third-party integration to focus the attention of Polywood where the sweet spot is, and that is manufacturing these recycled products. One tertiary benefits of this zero defect manufacturing is also the deployment of equipment and personnel utilization strategies, as well as asset management. Key critical components in all of this within the zero defect manufacturing implementation is the use of the system to help inform Polywood on what additional sensors, behaviors, technologies, information in general would be best suited to decrease scrap, increase performance, increase quality, while it's just having a general improvement of the overall manufacturing process. We believe that zero defect manufacturing is not a target, but rather the way in which Polywood will be moving forward within the manufacturing process. Anything more than zero defects would be considered a failure. So having the systems be smart enough to change their intrinsic algorithms and to have the system smart enough to determine what sensors or what locations or what information would actually benefit the process to align with previously agreed upon requirements is the foundation of Industry 4.0.
Polywood has been successful through training and experience, even though their process is currently mostly manually controlled. They have very little in the way of automation, automated control and monitoring, and very little visibility of scrap inefficiencies, as well as a clear gap between their current technology and smart technologies. Team Regor's recommendation is to implement a cyber-physical system to create a zero defect manufacturing system for greater automated control, greater data collection and analysis, and greater improvement visibility. Thank you for your consideration of our proposal.